I'm Michael Hansen, and I'm a math teacher here at St. Albans, and I've been doing it for a little over 11 years. This is my 12th year. For me, the most exciting thing to see is 12 or 15 or however many boys all fully engaged, all at the same time. The only way that I have in my arsenal of getting all of them 100% engaged at the same time is through games. Thomas.
What is a quadrilateral?
William.
Not here.
Austin.
What is QED?
Yes.
What is a complementary?
You have to spell it for full credit.
Oh.
M.
What is a crayon box but not the crayons?
What that?
What is the converse of the inverse?
Yes. That was the conversation.
Yes.
We played 3 games today. The first was Ask Backward Bingo, which is a computer-driven game that I sort of half invented. I generate random answers, which are in a 5x5 grid, and then I just pose questions. But since it's Ask Backward, the answers are actually questions and the questions are actually answers.
Was a square.
Well, that's correct. Now, is that a lucky guess, or
Nope,
did you
I
have
knew
some
that.
basis for that?
Because since the diagonals are congruent and because diagonals are perpendicular and because they form a right angle, it must be a square.
Not quite.
Could it
Plus,
also
I
be
need it to be the last one on my bingo.
Well, he should have said that we have a kite with a right angle. And a kite with a right angle, is that a square?
Yes.
I don't think so. I don't think so. I think we can make a kite with a right angle that's not a square. Let's take this diagram and let's see if we can alter it so that we have a kite with a right angle that is not a square.
I can.
I think we can do it, can't we?
Yeah.
No, you can't.
Yeah.
No, you can't.
Like that.
You can put a right angle there and a right angle here so that the opposite angles are right angles, and then make the long diagonal go like this, and then you have a right angle here.
And you gotta make the 2 diagonals congruent.
No, that's not.
Yeah.
Aha! So you were right, weren't you? Okay.
Actually,
Because this is not a fair diagram, is it?
nope.
Nope. We need to go the other way. Grab the marker and prove it to me. If you convince me, you get your double bingo.
Oh,
Since these 2 are congruent and perpendicularly bisecting, then this must be equidistant from
Yes.
this must be
Okay. So
equidistant
mark
from that.
those. Mark
And-
those.
And
Well, you can't do that much.
well, okay. So we got it here and here,
Yes.
and since here is also perpendicularly bisecting,
Right.
these 2 have to be here and here.
Yeah, but you can't use single ticky. You have to use some other
double
symbol.
ticky,
No, you can't
Triple
use.
ticky.
Yeah. There you go.
triple ticky.
How do we know they're bisecting?
And now we can use what is known as side angles. We can use a CP, CTC, and side angle side to prove that these 2 triangles are congruent by using reflexive property, because this is a right angle. We got side, side angle side,
Mhm.
and then this is congruent to itself,
Mhm.
and then the same thing over here. This is congruent to himself, and this is a that, and that's a that. And then we can probably both go SSS with dit, 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 dit. So that's actually not a right angle sign, it's just congruent sign. And since that's all corresponding parts, so this is congruent to this, and then that's congruent to that, and that's congruent to that, and that's congruent to that. If you add all using the property of addition, you get a square.
I'm not convinced yet.
Dude, that was complex.
I'm not
QED.
convinced yet. This is real math, because we're engaged in an argument, or at least most of us are engaged in the argument. We need to figure out whether he wins or not. Okay? Now, are you guys going to just roll over and accept his?
Yeah, because he
Draw a diagram that makes sense.
Well,
Maybe
how
I'll
many
get
to
to
believe
Oh my
you?
gosh, it looks like.
I think Luke was onto something. Like he was really close to getting it right, but I think his word choice may have just made it seem like he was in his messy diagram.
Okay, up to here, I totally agree with you.
Right.
Okay? We all agree with you up to this point, Luke.
And then with SSS, because you got this, so these 2 triangles congruent, right?
Yeah.
Yes, they're congruent to each other.
They're congruent to each other. And that means, and since these 2 are congruent, if you add it up, it would be that you get a whole. Wait, what was I saying? Can you use opposite angles to go with a right angle here as well?
Yeah, those are all 4 right angles. Whenever you have a right angle formed at a junction, how many right angles do you get, guys?
4.
4. Right. So you can mark all 4 of them. That's fine. No problems there. Okay. So now the question is, can we guarantee that this angle is congruent to this angle on the other side? You claim that we can.
Yes.
I claim that we cannot.
How do we prove it?
So we need to resolve this. Can you draw a diagram? I'm not saying you're wrong. I'm just saying that your reasoning at this point is not convincing me. Can we draw a diagram that has a right angle here that is still a kite?
Yeah. I go by way of contradiction.
That's an excellent idea. Did you all hear his idea? Proof by contradiction. Right. So try to draw a figure that has all of these requirements and assume that it's not a square. And then reason until you reach a contradiction. That would be one way of doing it.
One of the diagonals is bisecting at that right angle.
Oh.
And so we have, at every, there's right angles at every vertice. So
Wait. That's
I mean, not
the
vertice, not vertice. I mean, since that angle is being bisected, that's a 45-degree angle. The right angles at the right angles at the junction are a 90-degree angle, and I don't want to overreach, but I know that I know from because a square is a rhombus and a rectangle, so so all the angles are right angles, and then you get.
Oh, you're close.
You have 4 equal
You haven't quite
45,
sealed the
45,
deal yet.
90 angles.
Mark your
I mean,
first
triangles.
Can you add a comment here?
So if the opposite corners, I guess, are right angles, we could use.
Here and here?
No, like the bottom right one
Yes.
and the top left one are both right angles.
We don't know that.
Oh.
In a kite, no, the kite says that the ones along the long diagonal are congruent. Let's make a better diagram. I think that would help
Yeah.
us. We're going to stick a right angle there. We know that these angles are congruent. That's a property of kites. The question is, if these 2 angles are congruent, we stick a right angle here, what happens to the other corner? We don't know yet, do we? Carl?
Since AC perpendicular bisects DB,
Yes.
we know that because these are congruent to those, you tell that these are congruent, yeah, and that, but also because
It's elusive, isn't it? The second game we played was the quadrilateral always, sometimes, never game. This hopefully will eventually be an iPod app. Right now it is only on these antique computers that I have from 1983, and they're very easy to configure, very easy to program, and I just give one to each team, and then the teams choose always, sometimes, never. A typical question might be something like, a rhombus is a square. That's sometimes true, so the correct response would be to press the letter S. The questions are divided into easy, medium, and difficult, and the scoring depends on the difficulty of the question. The winning team today had a score of 55, which is a new all-time record. I congratulated them because that's really pretty amazing. My score in the first period was 29, but I only played for about half the time, so it was a pretty good score. All right, well, everybody turn your machines off, please. We'll close with the round of the association game.
Association game.
The final game we played is, it can be either a warm-up game or something to do at the end of the period as a reward, and we call it the association game. It's a sort of a cobbled-together game. I found the idea in a book somewhere, and then we made our own adjustments for teenage boys. We have no body parts below the neck, for example, and no proper names allowed. But a typical round, I throw out a noun, something like sand, and then each student has 1 second to come up with a word that either rhymes or is closely related.
Shoot.
Oh, that's below the neck, sorry. Okay. All right, so your word is tongue.
Mouth. Teeth. Lips.
head. Thinking.
Is a disqualification. Okay, your word is Never.
Always.
Sometimes.
Math.
Geometry tests.
Book.
Is a teacher, sorry. Okay, your word is last.
First.
Second.
Third.
This
Race.
is boring, we can't do that. Let's start with a better word here. Your word is fell.
Tower.
Church.
Synagogue.
Church.
Right.
He just
Okay.
said church.
The point is that when a student can't come up with an answer fast enough, or when he uses a filled pause like or then he's out. And of course, there's much laughter and hilarity that ensues, and everybody is totally engaged and thinking. It has nothing to do with geometry, of course, but they love it nevertheless. And I guess my philosophy of education, after having done it for most of my life, at least part-time or full-time for the last 11 years, part-time for much longer than that, we educators seem to have the notion that we are in a battle against ignorance. I know that was my philosophy for a very long time. Ignorance was the enemy, and we're doing battle against ignorance. I've decided that that's not the real enemy. The real enemy is boredom, or to put it another way, lack of engagement. And so if the boys are engaged, as they are during the always, sometimes, never quadrilateral game, I know that learning is taking place. 20 years from now, none of them will remember the intricate details of kites and rhombuses and parallelograms and so forth. They will remember, though, whether they basically enjoyed thinking and working together in a group. And if they can leverage that, then they've really got something. And so every time I see students arguing about some mathematical feature, I'm so happy. As long as they don't come to blows over their argument, I'm very happy if they're arguing. Arguing engages the emotions, and as we know, all of us on some intuitive level, emotion is the key to learning. If you've got strong emotions involved, learning will happen. I continually am fascinated by how my students know every mundane, arcane detail about the video games that they're involved with. They have no trouble whatsoever acquiring this data. Why? Because they care about it. It's emotionally important to them. And if we can somehow make some parts of the math curriculum equally important to them on an emotional basis, learning is no problem. I haven't solved the problem yet. When I do, I'll be rich beyond my wildest dreams. But I'm working on it.